In this very short lesson, we're just going to look at what the degree of a polynomial is, and we're going to look at degrees of 1, 2, and 3. So what is degree when we talk about polynomials? Well, I guess first of all, you should know what a polynomial is, because we haven't really talked about polynomials yet. We're going to talk a lot about them in the future, but for now, all you need to know is a polynomial is something like, I don't know, 2x plus 1, or 3x squared minus 5x plus 2, or I don't know, x to the 7 minus x to the 2. These are just combinations of letters, as in variables, and numbers, which are either coefficients or constant terms. That's what we mean by a polynomial. So when we talk about the degree of a polynomial, we mean the highest exponent on the variable. So if these were three different polynomials, if this was one polynomial, this was another one, this was another one, then the one in yellow would be degree 1, because it's assumed to have an exponent 1 on the variable, on the x. So that would be degree 1. The one in green would be degree 2, because it's got an exponent 2 on the x. There's another one that's got another variable that's got the exponent 1 on it, but it's not the highest, right? We want the highest exponent, so degree 2 for the green one. And again, degree 7 would be the blue one, even though there's also a 2, 7's higher than 2. So that's what degree means. So then we're going to look at just dimensions, as in first dimension, like 1D, 2D, 3D, and the units to go with them. So one-dimensional objects are degree 1, and their units have an exponent of 1, as we already saw, like in that yellow, highlighted in yellow is degree 1. So we might not even see the exponent 1 written there, because we don't usually, but we know those are degree 1. So for example, if we have a length of something, that line is 3 centimeters long, then the length is 3 centimeters, right? And the exponent that would be on the units is assumed to be 1, although we don't write that down normally. Or if something is x units long, then the length would be x centimeters. And again, x is just a variable. That's to suggest we don't know how long something is. Pardon me. So one-dimension things we generally call linear. Losing my voice. Great. All right. Two-dimensional objects have degree 2, and their units have an exponent of 2. So two-dimensional means things like what you can represent on a piece of paper, like, for example, a square. So area is something that's generally given in 2 dimensions, because the area would be 3 centimeters times 3 centimeters, right? And if we multiply that out, we'd get 9 centimeters squared. There's that degree 2 that we were just talking about. Or if something was x, remember these little lines mean that we have the same length on each side. That would be x times x, that dot means times. And so that would be x squared centimeters squared. Again, that degree 2. So 2-dimension, second dimension, generally is, we call that squared. And then final one, 3-dimensional objects have degree 3. Their units usually have an exponent of 3. For example, volume is usually in 3. Have a cubed, exponent's 3. So again, these little lines mean this is a cube, every side length is the same. So literally, the units would be 3 times 3 times 3, 27. So 3 cubed. And these units would be centimeters cubed. This one would be x times x times x, which would be x cubed centimeters cubed. So third dimension is generally called cubic. For example, if a square has an area of 64 centimeters squared, what's the side length? So the area is 64 centimeters squared. Every side length is the same. We know that for a square, the area is side times side, or side squared. So I could actually use this formula. Let's call it x for a side. So in that case, the area was 64, and the side is represented by the letter x. So 64 equals x squared, or I could rewrite it. I could switch the x. If you like to have, this is just an equation to solve, right? If you like having what you're solving on the left, I could switch sides. It doesn't matter. Remember, when we're solving an equation, we always do the opposite operations. So the opposite of squaring something is to take the square root of each side. That'll get rid of the square. And so square root of x squared is x. Square root of 64 is 8. And so it would be 8 centimeters. 8 centimeters times 8 centimeters would give us the area of 64 centimeters. If a cube has a volume of 64 centimeters, what's the side length? Well, a cube, I'll just freehand this one. It's got 3 side lengths all the same. Length, width, height, they're all the same. But the volume is 64 centimeters cubed. Volume, if we call these side lengths x, volume is equal to side times side times side. Times side. We just multiply all the sides together, which is the same as side cubed, right? But if we're calling the side x, then it's going to be x cubed. And if the volume is 64 centimeters cubed, again, if I want, I could switch it. Just switch sides if you prefer to see it that way. But in this case, I could take the cube root. There's actually something called a cube root. If I write a little 3 in there, and do that on the other side as well, that means if a square root means find something that you can multiply by itself to equal, whatever's under the square root sign, then a cube root means find something that you can multiply by itself 3 times that's going to equal what's under the cube root sign. Anyway, opposite of cubing something is taking the cube root, so those cancel out, leaving me x. And actually, most calculators, or many calculators, have cube buttons. If you take a look at mine in the bottom left-ish, you can see the square root sign underneath the a squared. You can see a sign underneath the a to the b, the exponent button, that says n root. That's where I can do any kind of root I want. So if I want to do a cube root, I can do 3, hit that button, and I believe, maybe not, maybe I haven't used that one yet. Maybe I have to hit the button first and then do the 3. Yeah, that seems to work. And then 64 underneath, and there, that's the cube root of 64. You can see my answer is 4. Let's think about why that makes sense, because it does. 4 times 4 equals 16. Times 4 again equals 64. A cube root is a number you can multiply by itself 3 times to equal what you started with. So if I started with 64, then 4 times 4 times 4, that's my 3 times, equals 64. That's my answer. Estimate the following square roots. Okay, estimate. So we're not going to jump straight to our calculator. We're just going to use a little bit of common sense and our knowledge of perfect squares. Hopefully you know that 3 times 3 equals 9. And 4 times 4 equals 16. And the reason I'm talking about them is because if I wanted to find the square root of 9, that means that the square root of 9 is 3 and the square root of 16 is 4. So working those perfect squares backwards. Square root of 10 is going to be very close to the square root of 9. It's only slightly bigger, right? So if I had to estimate, maybe I'd go 3.1. It's going to be a decimal or a fraction, but I'm going to go decimal. So 3.1. Let's check to see how close I got. Square root 10, 3.16277. Okay, not terrible. If I rounded it would be 3.2, but that's not terrible, is it? For square root 34, let's think about what's close to that. I know that the square root of 25 is 5, so that's lower than 34. Square root of 36 is 6. I just know my perfect squares. So 34 is close to 36. So it's going to be a little less than 6. So it's going to be 5 point something. What, 5.9 maybe? Let's check it out. .83. Again, I was off by a little bit, but I think that's all right. 77. Well, I know perfect square 64. Square root of that is 8. And the next one is 81, which square root of that is 9. So we're pretty close to being halfway between 64 and 81. No, actually, sorry, I take that back. We're closer to the 81. So maybe I'd go with 8.8. Let's try it out. Yay, that one rounds 8.77 rounds up to 8.8. Way to go, Mr. Begg. You got it exactly right on the last one. So there's a little bit of estimation we can use to help us solve those kinds of questions.